What if the explosion of two stars, two powerful earthquakes, and a colossal solar eruption all converged, right as a rare interstellar object, 3I/Atlas, barrels into our solar system? That's not a sci-fi pitch. It's the literal headline astronomers just logged. Two novas detonating, twin magnitude 6 earthquakes striking Venezuela, and a major coronal mass ejection projected to collide with the fastest alien comet ever recorded, all in a single, bewildering week. Is this just cosmic chaos, or are these freak events connected by something deeper? The evidence is mounting, and October's reckoning could change how we see our place in the universe. Every so often, something from deep space barrels through our solar system. A true outsider, not born of our sun or any planet. That's what makes 3I/Atlas so electrifying for astronomers. Before this year, only two objects like this had ever been confirmed. Oumuamua in 2017, a cigar-shaped mystery that zipped past Earth and left scientists arguing about its true nature, and Borisov in 2019, which looked and behaved more like a classic comet, but still carried the unmistakable signature of another star system. Now, 3I/Atlas joins this tiny club, discovered by the Atlas survey team in Chile on July 1st, 2025. It was first spotted more than 675 million kilometers from the Sun, already moving at a breakneck speed, over 130,000 miles per hour. That's faster than any asteroid or comet native to our own solar system. What sets 3I/Atlas apart isn't just its origin or its record-shattering velocity. Unlike Oumuamua, which never grew a tail and left behind a trail of questions, Atlas is clearly active. Even in the first images, a faint dust coma and tail were obvious, hinting at ice and dust boiling away as sunlight hit its surface. Hubble's cameras later picked up a dust plume and a shimmering tail, confirming that this was no inert rock. It was a living comet, shedding material as it dived toward the Sun. The nucleus itself appears small, maybe less than a kilometer wide, but precise measurements are still coming in. The color is a bit redder than most comets, raising questions about what kinds of cosmic weathering it endured before ever reaching our solar system. Tracing its path, 3I/Atlas slices close to the ecliptic plane, the same broad flat track where the planets orbit. That means it lingers near the Sun and the inner planets, offering astronomers a rare chance to study an interstellar visitor up close for weeks, not just a fleeting day or two. Its trajectory is so hyperbolic that there's no doubt. This object came from outside, and after its swing around the Sun, it will never return. Each observation is a once-in-a-lifetime shot to catch material from another star system, maybe even another kind of planet-forming disk. The excitement isn't just academic. Interstellar objects like this are the only direct samples we get from other solar systems, messengers from worlds we'll never visit. Every spectrum, every image, every change in brightness is a clue to how planets form, how stars die, and how the galaxy mixes its raw ingredients. That's why the survey teams, from Hubble to backyard astronomers, have dropped everything to watch Atlas as it approaches the Sun. For a brief window, the universe is sending us a visitor with secrets to share, and no one wants to miss what it reveals. Solar Cycle 25 is living up to its reputation as one of the most active in decades. Right now, the Sun is crowded with sunspots, anywhere from 165 to 200 at a time. That's not just a number for solar physicists to argue about. It means the Sun's surface is buzzing with magnetic storms, each one capable of launching massive bursts of energy into space. The F10.7 radio flux, which tracks the Sun's output at a wavelength of 10.7 centimeters, has been holding above 180 solar flux units for weeks. For context, values above 150 are considered a sign of real solar unrest. Above 180, the Sun is in overdrive. This isn't just a chart on a website. Every uptick in sunspot count or radio flux means more potential for flares, more coronal mass ejections, and a solar wind that's anything but steady. It's the kind of environment where the Sun can throw out a CME, a coronal mass ejection, basically a huge bubble of plasma, and send it rocketing across the solar system at hundreds of kilometers per second. That's exactly what happened in late September, when models from NASA and NOAA showed a major CME sweeping through the inner solar system right as 3I/Atlas was making its approach. Solar physicists have been tracking this escalation for months. The SILSO Sunspot Index and NOAA's Space Weather Prediction Center both flagged this surge as a key turning point for Cycle 25. The Sun hasn't been this active since the peak of Cycle 23, back in the early 2000s, and the timing couldn't be more interesting. With an interstellar comet barreling through, every burst of solar energy has a chance to interact with something completely alien to our solar system. The stakes go beyond astronomy. When the Sun is this volatile, it's not just comets and spacecraft that feel the effects. Solar storms can rattle Earth's magnetic field, disrupt satellites, and even trigger auroras at latitudes where they're rarely seen. But for now, all eyes are on the Sun's next move. Cycle 25's fireworks are setting the stage for a collision of cosmic forces, solar eruptions, interstellar ice, and the possibility of events we've never seen before. The question isn't if the Sun will throw another punch. It's who or what will be in the way when it does. Late September brought a rare convergence of cosmic and terrestrial violence. V1935 Centauri, a nova in the southern sky, erupted with a brilliance that briefly made it visible to the naked eye. What truly set it apart was the torrent of high-energy radiation. Fermi's Gamma-Ray Space Telescope and Swift's Burst Alert Telescope both registered intense gamma and hard X-ray flares from September 9th to 12th. The Fermi team measured a peak photon flux of 2.3 × 10 to the -6 photons per square centimeter per second, well above background. Integral's imager confirmed the spike in the 20 to 80 kilo electron volt range, matching the optical peak. Only a handful of novae have ever produced such gamma-ray fireworks. The violence behind these readings comes from shock waves blasting through the nova's shell, slamming into surrounding gas and accelerating particles to near light speed. Almost simultaneously, V7994 Sagittarii flared up, not quite as bright, but still visible through binoculars. Both novae appeared on AAVSO alert lists within hours, drawing in backyard observers and major observatories alike. Spectral data and light curves poured in, revealing classic thermonuclear runaways on white dwarfs. While the galaxy sees about 35 novae a year, 2 visible eruptions in the same region within days is rare enough to spark debate. Astronomers compared timing and spectra, searching for any sign of a shared trigger. V1935's gamma rays and rapid optical rise fit the textbook, but the clustering of these events kept speculation alive. Meanwhile, Venezuela's ground was anything but stable. On September 8th, a magnitude 6.2 earthquake struck near Cariaco just after 4 a.m. UTC. 6 hours later, a second quake, a magnitude 6.3, hit south of Cumana, less than 50 kilometers away. USGS data revealed a shallow depth of 12 kilometers for the first classic crustal strike slip. The second, deeper at over 30 kilometers, showed an oblique thrust, an unusual pairing for this tectonic corridor. Seismologists classified this as a true doublet. 2 strong quakes, close in time and space, but with contrasting depths and rupture styles. In northern South America, such doublets surface only once every 8 years. Emergency teams responded as buildings shook and crowds filled the streets. Some locals blamed the chaos on the comet blazing overhead. Others revived old beliefs linking cosmic events to earthly unrest. Scientists pored over seismic and GPS records, debating whether stress transfer between faults played a role. Aftershocks followed, but none matched the initial violence. By month's end, 2 stellar explosions and 2 major earthquakes had unfolded within hours. Each event was striking on its own. Together, they formed a pattern that defied easy explanation. Solar physicists ran the numbers as soon as the flare left the sun. NASA's Enlil model, the gold standard for space weather forecasting, showed a full halo coronal mass ejection launching on September 22nd at 15:36 Universal Time. The simulation projected a shock wave racing out at about 860 kilometers per second, spreading across the inner solar system. By the time it reached the orbit of Mars, the CME's envelope, basically a giant bubble of charged particles, lined up with the predicted path of 3I/Atlas. That's where things get interesting. The model's probability map gave better than a 60% chance that the comet's coma would be swept by the CME's leading edge sometime between September 24th and 28th. But here's the rub. The only way to be sure a CME actually hits a comet is to catch it in the act with a coronagraph. Soho's LASCO cameras and Stereo A's imagers both watched the CME erupt off the sun, but neither caught 3I/Atlas in the field after launch. The comet was too close to the sun's glare, lost in the noise, and no ground-based telescope could see it during conjunction. So, while the models say the CME and comet crossed paths, there's no direct image showing a tail disconnection, a sudden kink, or a burst of plasma, none of the classic signs caught in past events like Enki in 2007 or Lovejoy in 2011. Mars orbiters like Maven and the Emirates. Mars mission recorded a spike in solar wind density and a sharp magnetic field rotation right as the CME passed by Mars, matching the model's timing. If 3I/Atlas was in the zone, it would have been blasted by that same wave of solar wind. Theoretically, that should trigger a chain reaction, stripping ions from the comet's tail, maybe even causing the coma to puff up or brighten. Some amateur astronomers did report a rapid brightening of the comet, nearly 20 times what was predicted, right in the window when the CME was supposed to arrive. But with no direct images, it's impossible to say for sure if that was the sun's doing, or just the comet behaving unpredictably as it nears perihelion. Space weather analysts are split. Some say the modeling is strong enough to call this a likely hit, pointing to the timing and the outburst as circumstantial evidence. Others urge caution. Without a coronagraph image, it's all circumstantial. There's always the chance the model's missed by a few degrees, or that the comet's own activity just happened to spike at the wrong moment. The only thing everyone agrees on, if a CME did hit 3I/Atlas, it happened out of sight, and the evidence is indirect at best. This is the challenge with space weather and interstellar visitors. Even with the best models, the universe doesn't always cooperate with our cameras. For now, the case of the September CME and 3I/Atlas sits in limbo, plausible but unproven. The next time a big solar eruption heads for an interstellar comet, the world will be watching, hoping for a clear shot and a definitive answer. October is packed with moments that will have astronomers, and plenty of amateurs, counting down the days. The first big date lands on October 3rd, when 3I/Atlas swings past Mars at just 0.201 astronomical units. That's about 30 million kilometers, close enough for Mars orbiters like Maven or even Perseverance's Skycam to try for a snapshot. For ground-based telescopes, the comet and Mars will share the dawn sky, making for a rare double feature if the weather cooperates. Then, just as the excitement for Mars settles, October 21st brings another close call. Comet Swan, cataloged as C/25P1, will skim past 3I/Atlas in the sky. The two comets will be separated by only about 0.25 astronomical units, roughly 37 million kilometers. They'll both be near the Sun from our point of view, so the best hope for catching them together is with solar observatories like SOHO's LASCO camera. Still, the idea of two comets in the same patch of sky is enough to get every astrophotographer buzzing. The real fireworks are expected on October 29th, when 3I/Atlas hits perihelion, its closest approach to the Sun at 1.40 astronomical units. That's when solar heating peaks and the comet could brighten dramatically, or even show strange new activity. It's a high-stakes window for anyone hoping to spot tail disconnections or outbursts triggered by solar storms. And the show isn't over in October. November 8th brings Comet Lemon into the picture with predictions that it could reach naked eye brightness. Two comets visible in the same dawn sky is a rarity, and this stretch of weeks is shaping up to be a dream for skywatchers. For anyone with a telescope, or just a good pair of binoculars, these dates are circled in red. The clock is ticking, and every morning could bring a discovery. Patterns of doubles have a way of catching the eye. Two novae in the same week, two strong earthquakes hours apart, even paired comets crowding the October sky. But when you ask a statistician or an astrophysicist, the mood shifts from awe to analysis. In the Milky Way, about 35 novae erupt each year. Most go unnoticed, hidden by dust or lost in the glare of the galaxy's core. Two visible at once is rare, but not impossible. The same goes for earthquakes. Venezuela sits on an active fault zone, and while a doublet of magnitude 6 quakes is striking, it fits within the long odds that play out over decades. There's a tug-of-war between those who see cosmic meaning in these alignments and those who trust the numbers. Some researchers point to Suzanne Falsner's accretion theory, arguing that interstellar objects like 3I/Atlas are just debris, planet-forming leftovers flung out by young stars. Others, like Avi Loeb, keep the door open for more exotic possibilities, probes, or even superintelligent plasma riding the currents between worlds. The debate isn't just academic. Every time a rare event clusters with another, quakes, solar eruptions, theories multiply. Some propose that charged particles from solar storms could trigger seismic activity, or that interstellar visitors act as catalysts for change. But most peer-reviewed studies find no solid link, only coincidence dressed up as pattern. Still, the human mind is tuned to find order in chaos. Doubles and pairs stand out, even when the odds say they shouldn't mean anything. Whether it's a fluke or a sign of something deeper, the story keeps pulling us back to the question, how much of what we see is just the universe rolling its cosmic dice? In late September 2025, astronomers recorded two nova explosions, two magnitude 6 earthquakes in Venezuela, and a coronal mass ejection modeled to cross the path of 3Y/Atlas, only the third confirmed interstellar object, within a single 48-hour period. These events, each rare on their own, converged as 3I/Atlas accelerated toward the Sun at over 130,000 miles per hour, displaying unexpected brightening and tail changes captured by both amateur and professional telescopes. While solar models suggest a coronal mass ejection may have struck the comet, the lack of clear coronagraph images leaves this unconfirmed. Experts agree. Interstellar visitors offer unique opportunities to test our understanding of cosmic processes. but no direct evidence yet links stellar explosions, solar outbursts, and earthquakes on Earth. As new observation windows open in October and November, the scientific record remains open. For now, the facts underline how dynamic and how interconnected our solar system can appear when viewed through the lens of rare coincidence and careful observation.